So this is what we're going to use. We're going to use the protractor to solve this problem. So we need to first have a coordinate system. So our coordinate system is going to look like this. So this is I'm going to call this face. For face xz, remember that this is turning to turn this thing negative, so it's going to be 30, and also it's a compression, so it's negative 30 into negative 20. This force is trying to turn this thing. If we hold it here, you're gonna see this force is pushing it anti-clockwise in this direction, and then this one is compression. The compression is negative. So our stands for yz. Now we see that our yz is pulling, which is tensile, so it's going to be positive 45 or nabani, positive 20. So now we can choose a scale that is going to be a suitable scale. So now what I'm going to say is this is my scale. My scale is going to mean 1 centimeter is equal to, so yeah, it was 6, so I don't want a half that is going to be this big, so I'm going to use down here. So 1 centimeter represent 10 megapascal. Okay, this is my scale. So it means in this case, for this one, I'm going to write it in a scale format. So it's going to be 30 divided by 10, which is going to be 3. I'm going to have 3 centimeter into 2 centimeter into 45 pi, then into 4.5 centimeter into 2 centimeter. Okay, so this is my 0. I will act as if my 0 is somewhere here. So this one is bigger and that one is bigger than that. So let me project it here. So yeah, I'm gonna say this is my 0 point. This is my 0. So from 0 we're gonna go 4.5 this way. 4.5 centimeter. It's something like this. Okay, so to be accurate, I'm gonna use this side. So it will look something like this. So it's gonna look something like this. Okay, so now I'm gonna have 1. It's 1, 2, 3, 4.5. It's gonna be this dot. That's our 0.5 for there. And then again, you come to this side. This side we have 3. So count 3. From there, 3 is here. This is 3. That's our 3. Okay. So now I'm gonna put here. This is 3. And then this is 4.5. Hope it's still clear there. Okay, let's go ahead and try to define the axis. I'm defining the axis now. Okay, so we said our y is there 2 centimeter, so we're gonna use this again. So 1, 2. So it's 1, 2. So my 2 is okay. I'll just use my centimeters, but it's still the same thing. So my 2 is here. This is my 2. And same thing this side. This is where my 2 is. -2, -3. So these ones, they act somewhere here. Okay, right, so now I'm gonna join these 2 lines. These 2 lines supposed to join like this, like that. So it's passing here all the way to there. Okay, so this means this is our center, which is this is our C. So now we have these 2 points of interest. Okay, so it's gonna look something like this, and then now we go ahead. We're going to use this. Okay, so from this we want to make sure that we open this up until it reaches to that point, and then put it here until it reaches to that point. You can see most, right? You can see also this side is going to reach to the same point. Okay, okay, I hope you see something there. Okay. And then from there, whenever it's passing x, it means that it's a principal stress. That is our principal stress there, located at x, situated at x. I mean, that x, that point. These 2 points. This is what we are looking for, and also this maximum point here. This one's also a point of interest. That one and this one. It's a minimum value of that one here. Okay, so now we have defined two things now already. So we have this one. Okay. And this one, this side. It matches here. It matches there. It matches here. Okay. Let alone of this line. So we have defined this line. I mean this principal stress 2 and our principal stress 1. These are our principal stresses. Now we need to get the values. How are we gonna get the values? We're gonna measure again. This is how we get the values. We measure from that point there to 0. So this is 5. I have 5 here, as you can see. From this 0 up to there, I have 5. So this is 5 centimeter. Né? And then from here to here, let me use this for accuracy. So it's gonna be something like this: 0 0.5, 1, 2, 3, 0 0.8. So this is 0 0.8 centimeter. And then we come here again. Then for this one, yeah, we have about 1, 2, 3 point 1, 2, 3, 3.3, né? 3.34, almost 3.4. I'm gonna say 3.4. This side is 3.4. We have 3.4 this side. Okay. So now we're gonna convert these ones back now. Okay. How are we gonna convert? How are we going to convert them? Just like this. So now we have principal stress 1. Because I'm small. Small. Don't forget that. Yeah. 50 megapascal. And then principal stress 2. 3.4 times 10, which is 34 megapascal. So these are our principal stresses we have found using our compass method. I mean our protractor method. So let's go ahead and look for. Remember the angle is twice now. We are moving off the triangle or off the principal. I mean moving off this body. We're coming to this. So the angles in this they are times 2. So now we're gonna say our theta is equals to 2 times 25, which is equals to 50 degrees. Né? So this is our theta. Okay. Yeah. Guys, I see that I almost made a mistake. Remember that okay, this is this now. Okay, so now if we want to measure this angle, which is on this line, okay, or in this small circle, yeah, so now we're going to measure this first. Remember that when you take this thing out to this one, it is 2 times, so hence why we're going to have 50 of this angle in this small circle. So this 50 is going to be measured from this line, which is, remember that we're measuring with respect to what. So I'm going to name this. If I'm naming this, let's say I'm gonna name this C, and then this is CB, this is your A, this is your B, then this is your D. So now if it is measured with respect to CB, okay, which is, I mean CB, you see, this is your CB, this is your CB. So this is going to be your C, this is going to be your B, okay. So now from this CB, we're going to measure this with respect to CB. This is CB, guys, okay. So now remember, this is what we're going to do. We're going to do it like this, and then we make it so that it's going to be at 50 degrees to this line. So now we're gonna go from all the way to 50. So this is our 50, guys, okay. So from this, I'm sorry about this, not straight, but okay, yeah. So now this is our 50. So our 50 is measured from this line. So it's 1 2 3 4 5, okay, or 1 2 3 4 5, okay. So now this is what we're going to do. This is 50, and then we're going to measure this angle from this line. This is CB, so this is 2 theta, okay. So this is 2 theta, and then now we're going to go ahead and try to get this, which is this thing. This is going to be this, okay. So now we're going to see that this is almost this, guys. So this one, this is our shear maximum anyway. So our shear maximum is going to be nothing but that 42.5 we got there. And then now we're going to measure this one. How far is this one from this 0, okay. So now we're going to measure and see how far is it. So it looks like it's 1.67. So we're going to say it's 1.7. I'm going to say this is 1.6 or 1.7. We can say 1.6 either. So this is 1.6 meters away, centimeters away. So now because this is 1.6, so we get to name this 1.6. This is what we are looking for, which is our normal stress, guys. Or this is what you are looking for, our normal stress. to this plane AB, okay? So which is what? Is 16. So this is 16. 16.8 megapascals, okay? This is it, guys. This is what we were looking for, okay? So now you can see what is that value that it reads like 42, almost like 42. So it corresponds to 42, guys, okay? So this one, I'm gonna measure this one, that side. It looks like it's also 42. It's somewhere there, okay? So all the way to that. This is another thing. So we have this now. So this is what you can share. This is our share, okay? Which is it's a share. It's a pair to this one. Remember, these are the pair. So this is our share. I'm gonna call it a share. So this shear force is nothing but 42 megapascal, okay? So this is it, guys. This is how you do this. So they were looking for this. Let's see if this is correct by looking on the existing example. What did they get for the normal stress, okay, at that plane AB? Okay, so now this is what they got. They got 16.28, which is their normal stress, which is what we got here, guys. This is 16.80. They got 16.28, so it's going to be almost a rough number. Yeah, well, so this is their share. We also got almost 42, which is almost the same thing. This is this. It's very simple when you have the protractor. You can do it now over and over again, okay? On my side, I say thank you.